students. So in this video we will see numericals from model question paper. So first one, that is 44th question. There are two charges, 2 microcoulomb and 8 microcoulomb, separated by a distance 4 centimeters. So first I will take, there are two charges. So one I will take it as Q1, 2 microcoulomb, and second I will take it as Q2, 8 microcoulomb, and distance between them is 4 centimeter. 4 centimeter. You are required to find force between them. So by Coulomb's law, force between them is given by, I will take it as F1, 9 into 10 raised to 9 Q1 into Q2 divided by R square. So if I substitute the values, 9 into 10 raised to 9 into Q1 is 2 into 10 raised to minus 6, Q2 is 8 into 10 raised to minus 6, whole divided by R square. R is in centimeters, so 4 into 10 raised to minus 2 meters bracket square. So simplify this, you will have force, that is 9 into 2 into 8, or you can say 9 into 8 to the 16 into 10 raised to power minus 12 plus 9 is minus 3 divided by 4 square 16 into 10 raised to minus 4. So 16 gets cancelled. If you simplify, you will have 90 Newton. Now in second part, the distance between charges is halved. The distance between charges is halved. So means here now R becomes 2 centimeters. So here R becomes 2 centimeters. And a medium of dielectric constant 2 is placed between them. So now we are having dielectric medium. So epsilon R is equal to 2. So find the new electric force. So again by Coulomb's law, I will take force as F2. So you will have 9 into 10 raised to 9, as a dielectric medium is there, divided by epsilon R, Q1 into Q2 divided by R square. Now substitute the values. So now substitute the values and simplify. You will have the new electrostatic force. So 9 into 10 raised to 9, epsilon R is 2, Q1 into Q2. So Q1 is the same, 2 into 10 raised to minus 6, Q2 is the same, 8 into 10 raised to minus 6, whole divided by R square. Now R is 2, it is in centimeters, so 10 raised to minus 2 bracket square. So if we simplify this, so this 2 gets cancelled, you will have 9 into 8 into 10 raised to minus 3 divided by 2 square 4 into 10 raised to minus 4. Now simplify this, 4 to the 8, 9 to the 18, so you will get around 180 Newton. 180 Newton new force. Find change in force he has asked. So third, if I take change in force, I'll write it as a delta F, that is nothing but F2 minus F1. So 180 minus 90, that is equal to 90 Newton, and force has increased. So increase in force is there. Clear students? This is first one. Now second, if we take a parallel plate capacitor consists of two circular plates each of radius. So first he has given a radius of each plate. So R is equal to 1.38 centimeters. I will write it in meters. A coating of Teflon 40 micrometer thick is applied on inner surface of one plate to provide a dielectric layer. Then the plates are pressed together. So thickness between two plates, that is distance between two plates D, he has given 40 micrometer, or you can say 40 into 10 raised to minus 6 meters. Find the voltage to be applied between plates. We are required to find V. To establish a charge of, so Q he has given 0.5 nanocoulomb, 0.5 into 10 raised to minus 9 coulomb. Given epsilon naught he has given, and dielectric constant of Teflon he has given. So epsilon R is equal to 2. So now if I take for parallel plate capacitors. So for parallel plate capacitors, if I take formula. So for parallel plate capacitors, C is equal to A epsilon naught. Here dielectric medium is there. So epsilon R divided by D. So C is nothing but Q by V. So Q by V is equal to A epsilon naught into epsilon R by D. He has asked us to find the V. So I can write this as V is equal to Q into D divided by A epsilon naught into epsilon R. Now substitute all the values and simplify. Substitute all the values and simplify. Therefore, V is equal to 0.5 into 10 raised to minus 9 into D is 40 into 10 raised to minus 6 whole divided by A. A is area. So circular plate he has told. So I can write it as pi r square. Pi r is 1.38 into 10 raised to minus 2 bracket square into epsilon naught 8.854 into 10 raised to minus 12 into epsilon r, that is epsilon r is 2. Epsilon r is 2. So 8.854 into 10 raised to minus 12 into 2. Now simplify this. First I will multiply the numerator. So if I multiply both the numerator 0.5 into 40, so I will get 20 into 10 raised to minus 9 minus 6 is minus 15 whole divided by pi is 3.142. So 1.38 square if I take 1.904 into 10 raised to minus 4 into 8.854 into 10 raised to minus 12 into 2. Now I will simplify this. So this is equal to 20 into 10 raised to minus 15 divided by. So multiply all the terms in the denominator. If you multiply, you will have 105.95 into 10 raised to minus 16. 10 raised to minus 16. Now divide 20 by 105.95 and simplify those powers. So if you divide 20 divided by 105.95, you will get this is equal to 0.188 into 10 raised to 1. 10 raised to 1. So that is nothing but 1.88 volt. 1.88 volt. Clear, students? Next, third one. Third one. Two cells of EMF 3 volt and 4 volt and internal resistance 1 ohm and 2 ohm are respectively connected in parallel. So first, two cells are there connected in parallel. So as to send current in same direction. So I'll take two cells connected in parallel so as to send current in the same direction. So two cells are there connected in parallel and they are sending current through an external resistance in the same direction. So 3 volt 1 ohm. So I will take E1 is equal to 3 volt, R1 is equal to 1 ohm. So first cell. Then second cell 4 volt. So E2 is equal to 4 volt, R2 is equal to 2 ohms. So they are sending current in same direction across an external resistance of 5 ohms. So R is equal to 5 ohms. You are required to find potential difference across this resistance. You are required to find V. So first I will find effective EMF. So I will write it as E, or you can say E net. Effective EMF. It is given by E1 R2 plus E2 R1 divided by R1 plus R2. Divided by R1 plus R2. So if I substitute, so this is 3 into 2 plus 4 into 1 divided by R1 plus R2, that is 2 plus 1 plus 2. So if you simplify, you will have 3 2 is 6, 6 plus 4, 10, 10 by 3 volt. Then we will find effective internal resistance small r, or I will write it as R net. So you can take this as E, even you can take this as R. So it is given by R1 R2 divided by R1 plus R2. So now if I substitute, it is 1 into 2 divided by 1 plus 2. So effective internal resistance is 2 by 3 ohms. Then third, main current or total current I is equal to, that is current through external resistance. I is equal to E by R plus R. So now I will substitute these values. E is 10 by 3 divided by 5 plus 2 by 3. 2 by 3. So now if you take the LCM, 3 gets cancelled. You will have 10 divided by 15 plus 2. That is nothing but 10 by 17 ampere. 10 by 17 ampere. So this is current across external resistance. So now voltage across, potential difference across 5 ohms. So potential difference across 5 ohms, that is V. V is equal to I into R. So if you substitute, I is 10 by 17, R is 5. So you will have 50 divided by 17. 50 divided by 17. So divide 50 by 17, you will have the answer. So 50 divided by 17, 2.94, you will have the answer. So this is equal to 2.94 volt. 2.94 volt. Next, so two circular loops of radii 6.28 centimeters and 3.14 centimeter are arranged concentric to one another with their planes at right angles to each other. So I will have a rough diagram. So one circular loop is there. So circular loop 1. So another loop concentric with this. So concentric with this concentric. So their magnetic field at the center will be both perpendicular to each other. So this you can take that due to 1. So another magnetic field will be perpendicular to its coil. So another magnetic field is in this direction. So two circular loops of radii. So I will take R1 6.28 centimeters into 10 raised to minus 2 meters. R2 3.14 centimeter, that is into 10 raised to minus 2 meters concentric. Current of 2 ampere is passed through each of them. So current in both coils is same. So I1 is equal to I2, that is equal to 2 ampere. You are required to find magnitude of resultant magnetic field at their center. So magnetic field at their center. So both these are perpendicular. So resultant you will have at the center. So resultant magnetic field at the center. So resultant I will write this as B resultant or B net, or you can say resultant magnetic field BR. So first we will find B1 and B2. Then as the angle between them is 90, then we will find the resultant. So first magnetic field at the center. So formula is B is equal to mu naught Ni divided by 2R. So in both cases N is equal to 1. In both cases N is 1. So first I will calculate B1. B1 is equal to 4 pi into 10 raised to minus 7. N is 1. Current is 2 ampere divided by 2 R1. So 2 into 6.28 into 10 raised to minus 2. So if we simplify this, so 2 gets cancelled. 4 pi is 3.14, so I will take it as 14 into 10 raised to minus 7 divided by 6.28 into 10 raised to minus 2. So simplify, you will have 2 into 10 raised to minus 5 Tesla magnetic field at the center due to first coil. Now if I take due to second coil B2, so formula is same, 4 pi into 10 raised to minus 7, number of turns is 1, current is same, only changes is radius. 2 into 3.14 into 10 raised to minus 2. So again, if I substitute, this 2 gets cancelled. You will have 4 into 3.14 into 10 raised to minus 7 divided by 3.14 into 10 raised to minus 2. So 3.14 gets cancelled. You will have 4 into 10 raised to minus 5 Tesla. Now you are required to find magnitude of resultant magnetic field at the center. So resultant magnetic field at the center. Resultant magnetic field at the center. So that is B resultant is equal to, as both are perpendicular, you will have root of B1 square plus B2 square. Now substitute the values. So root of 2 square plus 4 square outside root 10 raised to minus 5. So simplify, you will have the answer 4.47 into 10 raised to minus 5 Tesla. 4.47 into 10 raised to minus 5 Tesla. Next one, an object is placed at 10 centimeters in front of a concave mirror of radius he has given. So rough if I take, so concave mirror, so this is pole, so you'll have to you have focus and center of curvature to the left of the pole. So object is placed, so he has given u is equal to minus 10 centimeters. So concave mirror radius he has given, so radius means from P I am required to move to the left, so means you will have negative minus 15 centimeters, means focal length is r by 2. R by 2 means you will have minus 15 by 2 centimeters. You are required to find a position, magnification and nature. So first by mirror formula. So by mirror formula, you calculate V. So by mirror formula, if I write 1 by U plus 1 by V is equal to 1 by F. So 1 by V is equal to 1 by F minus 1 by U. 1 by F minus 1 by U. 1 by U. So substitute. So F is 15 by 2. So 1 by F will be 2 by 15 negative. So minus 2 by 15. So U is minus 10. So this is plus 1 by 10. So simplify. If you simplify, this is LCM will be 30. So minus 4 plus 3. So you will have minus 1 by 30. Minus 1 by 30. So therefore V will be equal to. So V is equal to minus 30 centimeters. V is equal to minus 30 centimeters. So V is negative. So image is formed to the left. So real image is formed. Real, as it is negative, always real will be inverted. So inverted image is formed. Image is formed. Now second, magnification. So magnification is given by formula m is equal to minus v by u. Minus v by u. So if you substitute, so minus v is minus 30, u is minus 10. So you'll get magnification m is equal to minus 3. So negative sign indicates inverted and it is magnified 3 times. So magnification is 3 times. Negative sign indicates image is inverted. Image is inverted. Clear, students? So this is on optics. Then finally on wave optics, another problem you have. So two narrow parallel slits separated by 0.850 mm. So he has given separation between two slits. I denote it by small d, 0.85 mm or into 10 raised to minus 3 meters. Illuminated by light of wavelength lambda he has given. So lambda is equal to 600 nanometer. And the viewing screen is placed. So distance of screen capital D he has given 2.80 meters. Find phase difference between two interfering waves on the screen at a point 2.5 mm from the central bright. So distance of fringe he has given, so I will denote it as y. He has given it as 2.5 into 10 raised to minus 3 meters mm he has given. We are required to find phase difference for that first. And second, ratio of intensity at this point, that is resultant intensity by maximum intensity I am required to find. So first, we are required to find path difference for that point. So path difference for a point y is equal to 2.5 mm. So path difference delta x is given by y into small d by capital D. Y into small d by capital D. So if I substitute, so y is 2.5 mm, so 2.5 into 10 raised to minus 3. Small d is 0.85 into 10 raised to minus 3 whole divided by capital D. So 2.8. So if you simplify, you will have 0.7589 into 10 raised to minus 6 meters. So now, once we know path difference, I can calculate phase difference. So phase difference is given by formula phi is equal to 2 pi by lambda into delta x. Phase difference is given by 2 pi by lambda into delta x. Now substitute. Lambda he has given, delta x we have calculated. So if I substitute, I will have 2 pi divided by 600 nanometer. So 600 into 10 raised to minus 9. Delta x is 0.7589 into 10 raised to minus 6. 10 raised to minus 6. So simplify. If you simplify, you will have, so around, if I cancel this, it is pi by 3 into 0.7589 into 10 raised to minus 6 divided by 2 zeros. If I take to this, it is 10 raised to minus 7. So 2 and 6 I have cancelled. 600, 2 zeros I have simplified with 10 raised to minus 9. So this is pi by 3. If you take this to the numerator, it will be 7.589. 589. So this is around 2.5 pi, or you can say 5 by 2 pi. Phase difference is 5 by 2 pi, or you can write it as 5 pi by 2 radian. 5 pi by 2 radian. So if you want, you can substitute the value of pi and simplify. You will have the phase difference. So even if you want, you can substitute the value of pi. So substitute the value of pi and simplify. So you can do even in that way. So 5 into 3.142 divided by 2. So you will have 2.5 into 3.142. So 7.855 radian. 7.855 radian. So this is a phase difference. Second, he has asked intensity ratio. So we know that resultant intensity at any point is equal to intensity of central maxima into cos square phi by 2, where phi is phase difference between those. So now if I take ratio resultant by I naught. So this is equal to cos square phi by 2. So now substitute. So if I substitute the value IR by I naught, cos square phi is 5 pi by 2. Phase this in radian I am taking. So this is 5 pi by 2 divided by 2 equal to cos square 5 pi by 4. 5 pi by 4. So if you simplify, you will have minus 1 by root 2 bracket square. So ratio will be 1 is to 2 or 1 by 2. So 1 by root 2 square is 1 by 2. Clear, students? Next, on radioactivity we are having. So half-life of radon he has given. So half-life is 3.8 days. So I will take T half. 3.8 days. You are required to find decay constant. So first, decay constant lambda is equal to 0.693 divided by T half. Substitute the value in seconds. So 0.693 divided by 3.8 days. So 1 day is equal to 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. So if you simplify this, you will have in seconds. So simplify this, divide by all these terms. Finally, you will have answer 0.211 into 10 raised to minus 5 per second. Per second. Now in second part, after how many days 5% of sample is left, he has asked. So after how many days it is. So he has given n is equal to 5% of n naught, means 5 by 100 n naught. 5 by 100 n naught. So you are required to find t. So we know that n is equal to n naught by 2 raised to n, where n is equal to t divided by t half. Now substitute in this and simplify, you will have the answer. So first if I take n is equal to n naught by 2 raised to m. So 5 n naught by 100 is equal to n naught by 2 raised to n. So n naught gets cancelled. So 1 by 20 is equal to 1 by 2 raised to n. Therefore, 2 raised to n is equal to 20 if I cross multiply. Apply log on both sides. You will have value of n. So if I take log on both sides, n log 2 to the base 10 is equal to log 20 to the base 10. So this is n into, use log table, you will have 0.3010 is equal to log 20 is 1.3010. So n is equal to 1.3010 divided by 0.3010. If you divide, you will have n is equal to 4.322. 4.322. So now substitute in n is equal to t by t half. You will have t. So from this formula, I will write t is equal to n into t half. So n we have calculated 4.322 into t half is 3.8 days he has given. So if you multiply, you will have 16.42 days. 16.42 days. So these are the problems from model question paper. Hope it is helpful to you all students.